biggest challenge for higher education is that we will have to make a massive investment in order to become entirely carbon neutral. Decarbonizing our energy is costlier than people realize. It's a big scale problem, and most people don't really understand the full scale. Now, the scale of not doing that is even more massive, and that's why we're committed to try to figure out what investment has to be made. We're trying to manage that problem and minimize the investment that will be required to become carbon neutral, but not to do that has enormous consequences that actually have real costs associated with them. Those costs are enormous, and there is no accounting system that I know of that actually creates a ledger that says these are the investments needed and those are the costs if we don't act. But they really are out of proportion, massively big in both cases, but the cost of not doing anything is much, much greater in my opinion. I work for the University of California, which is supported by the taxpayers of California, and in California there's a strong feeling that public higher education should be on the leading edge in terms of being more progressive about using research in ways that solve society's most pressing problems. And even beyond California, I think the same feeling exists, certainly not just for public education, but for private education as well. Society expects higher education to be in the lead in terms of environmental stewardship. It's just that simple. I think one of the things that challenged me personally about this is I like really big problems. And the idea of getting the entire University of California to a point of carbon neutrality is a problem so big that when we made a commitment to solve that problem, we had no idea exactly how we'd get there. And we're still not certain that we have the framework in place to get there. We think we do now, but it's a really audacious problem. And I like problems that are really big. Well, the most positive thing about it is as difficult as some of the things are that we have to do, there's almost no resistance in a way. I mean, everybody wants to do the right thing. Sometimes people are surprised that it will cost more than they thought it might cost, or that it takes longer than they hoped it would take. But so far I haven't seen enthusiasm waning because of discouragement. I've seen a resilience about the determination, especially in the part of young people who I think really do understand that this is not just a trendy one-time event in their educational development. This is something that's going to have a lifelong impact, and students approach it that way, and I think that's a very good thing, actually. I think the best advice that I do give young people, students, is to get an education which is as technical as possible. The problems that they need to learn how to confront are not simple. They require a knowledge of biology or physics or engineering or law or policy, but the depth in each of those areas has to be pretty significant to really grasp the complexity of the problems we're talking about with global warming and climate change. And actually the other part of an education that sometimes doesn't work well unless a student makes it work is you have to have a systems integration kind of way of thinking. Sometimes our isolated disciplines function as silos, where getting a systems way of understanding climate models, for example, is hard to do. Now, a lot of our universities are trying to improve upon that very aspect of sustainability education, but systems thinking, understanding big models, this is really important. And the kinds of technical education that can really make that feasible involve informatics, it involves understanding data systems, data analysis, modeling, physical and biological sciences. And then I think just as important are areas that like law and social policy and government policy issues. Those have as much to do with the secondary impacts as well.